Okay, so now that we've learned how to name ionic compounds, we're going to practice figuring out how we get those chemical formulas. So the first step in writing a chemical formula is figuring out the oxidation number. The oxidation number is the number of electrons that an atom will lose or gain in order to bond with another element. So if you remember from the last notes, metals want to give up their valence electrons and in order to have a full outer shell, whereas nonmetals want to take electrons. Well, the number that they give away and the number that they take is their oxidation number. The oxidation number, similar to the valence electron number, is determined by the group it is on the periodic table. But remember, the oxidation number is different than the valence number. Valence is how many electrons are in that outer shell. An oxidation number is how many of those valence electrons the atom will give up or take in order to become stable. So here on your periodic table, and if you have your periodic table with you while you're taking these notes, make sure to draw this on your periodic table. So the pluses and the minuses here at the top indicate for that group what their oxidation number is. So all the ones in the first group have a +1 oxidation number. All the ones in the second group have a +2. Transition metals, just like normal, can kind of vary. Borons group have 3. The carbon group can have a + or -4. Nitrogen will have a -3, oxygen group will have a -2, the halogens will have a -1, and the oxidation numbers for the noble gases is 0. This is because they already have 8 and they don't want to take any more and they don't want to give anything up. So they're not going to be participating in bonding with anybody. The plus sign, if you remember, a cation is something that gave away negative charge. Well, those plus signs on those first 4 columns means that they gave away 1 electron, 2 electrons, 3 electrons, or 4 electrons. The negative means they took that negative charge. So all the ones in carbon group will take 4. All the ones in the nitrogen group will take 3. All the ones in the oxygen group will take 2. The halogens will take 1. And again, the noble gases won't take any. So it's going to be very important that you know and can determine what the oxidation number is for every element on the periodic table. Now, metals will give up all of their valence electrons. This is why their valence electron is the same as their oxidation number. So I'll say that again. So the metals want to get rid of all those valence electrons that are floating around that outer orbit. So that is why their valence number is the same as their oxidation numbers. Nonmetals, however, that's not the case. Nonmetals will only take electrons. They're not going to give anything up. So this makes them happy and stable. So a nonmetal, for example, like fluorine, has 7 valence electrons around its outside. Its oxidation number is not 7. Its oxidation number, if you look back on the last slide, was a -1, meaning it will take 1. So you look at how many valence electrons they have and how many it would take to get to 8. So if something has 6 valence electrons, it needs to take 2 more to get to 8. So its oxidation number is 2. If it has 7, it needs 1 more to get to 8. So it's going to take 1. So its oxidation number is 1. So, why do you care about oxidation numbers? Because the oxidation numbers will determine the subscripts when you write your chemical formulas. So, the first thing that you got to do is determine each element's oxidation number. So you'll go element by element and look at its oxidation number. You're going to crisscross and drop the oxidation number and drop the oxidation numbers down to the other element, and they will become that other element's subscript. and then you'll drop it like it's hot. And by that, we mean drop the charges. So you're not going to write subscripts as having a plus or a minus. It's just going to be 2 or 3 or whatever the case is. And we'll do some examples so you know what I mean. Okay, so step 1. So let's say we're bonding potassium and we're bonding nitrogen. The first thing we do is figure out their oxidation numbers. So if you look at your periodic table, you'll see that potassium is in that first column. It's a metal, so it's going to be a plus. Nitrogen oxidation number is a -3. So we're going to crisscross. So potassium's oxidation number is going to become nitrogen's subscript. Nitrogen's oxidation number is going to become potassium subscript. So you're going to take that 1 and you're going to swing it down to that nitrogen. You're going to take that 3 and you're going to swing it down to that potassium. Okay, so that 3 is now right here. And that 1, we don't write the 1. It is just understood to be there. So you don't actually write a 1 as a subscript, but if you don't see 1, you just understand that it's 1. So the 3 that's now on the potassium came from the nitrogen. So we crisscross them and drop the signs, and that becomes the subscripts. So this is the chemical formula for potassium nitride.